very structure in terms of how to approach the system design question. Okay. So when I talk about structure, what I mean is they don't have a recipe in their mind how to approach. All system design questions at a high level are the same, right? And that realization that everything is pretty much it's the same, it's just problem solving, right? But you need to have an approach and that's how with with a lot of trial and error, we figured out like, okay, what works in the FANG companies and what doesn't work in the FANG companies. So what they want, what the interviewer is looking for is, do you have a template that you can use on any question, given any system design question, you apply the template and you should get the answer. Okay.
Right.
We broke this into a 9-step process. We have a 9-step process that I developed. And this has been successfully used in interviews in TPMs. They have been used in senior SDs, staff level SDs, director level, senior manager level. So till that level, we have kind of perfected this art. Okay. So the step one of this thing is, whenever you hear a question, what happens is that people don't know where to start. Okay. And on the internet, what you will see is, hey, start with functional requirements. Okay. But that is not really the true picture. There is a little more depth, a little more structure. That is what I found when I have coached around 350 people. Okay. And what I've seen is that if you tell somebody, hey, start with functional requirements, it just doesn't cut it. It is still at a very, so over iterations, what we found is that you need to first start with just generally understanding the problem, right? And then starting to identify actors. Okay. So the first 7 minutes of your interview, you need to actually figure out like who are the actors in this system, what are their actions in these systems. Okay. And then after that, you start to get an understanding of use cases. Okay. What you will see outside on the internet is that, and that doesn't work very well, is that they'll ask you to get into use cases. Okay. So the first thing I tell people is try to identify the actors, and there can be multiple actors in the system. Okay. Like for example, let's take an example. Let's say you are asked to design the tiny URL service. Right. So who are the actors? Now, everybody understand what tiny URL service is, correct? It's basically taking a long URL and converting it into a short. Correct? So now who are the actors? How do those actors behave? Right? That is very important. So let me ask you, Jay, who do you think are the actors in this?
So most importantly, the SDs, development engineers. Sorry?
When I'm talking about tiny URL, the actor is people who are going to use the system.
Right.
Right. So the tiny URL service, who are the people who are going to use the system?
I think it will be the engineers who are designing or developing the system.
No.
Okay.
I think this is where the difference is, right? This is exactly what happens when people, right, they don't understand who an actor is. An actor is somebody who uses the system. So for example, in the tiny URL service, it could be you or me who want to take a long URL, convert it to a short URL and send it to their friends. Right?
Okay. Yeah.
That's an actor. And similarly, if you look at, if you think about these actors a little deeply, there are different flavors of these actors. It's not just one single actor, right? Like for example, there could be a person who's a marketer who wants to use this tiny URL service to convert a long URL into a short URL and then distribute it on Facebook, Google, and Amazon. Right? He is also an actor, a different flavor of that actor. Right? And a lot of people what I've seen in the interviews is that they don't have that strong, what I call this a product sense. Okay? They don't have a strong, well-developed product sense. Right? Like for example, in your case, you are talking about software development engineers as being the actor. Right? No, so but the actors are these people who are, and then the other actor is the person who's going to use that short URL, right? So that is the other actor who is the, so these are the two identify actors, and they like I told you, right? Every actor, you need to not only think about the actors, but also subcategories of these actors. Then I think at a FANG level, then you are in a good shape. Okay. Because if you don't do this, if you identify this, you are at, I would say, like 70 percentile of people will do this, right? But that doesn't cut FANG. You need to be at the 90th percentile to clear FANG interview. Makes sense? So the actor identification, then once you've identified the actor, now the next step is to kind of understand how does he behave, how does he interact with the system, right? And this is also a very important step that you have to actually, if you go too fast on this, then you will not get enough details. So you need to think about your interviews as this is the best version of you in a real work environment, right? So given this problem in a real and work environment, how would you solve it, right? What people tend to do is they dilute their work, what they do at work, they dilute it in the interview actually. It should be the other way around. You need to be more deliberate in an interview than at your work. Because at work, you have 4 other people who will correct you. Here, you don't have those 4 other people. You are the one. Right? So these are a couple of things that make people. So think about when you're designing the system, think about that somebody is just going to give this to a junior SD1 or an SD2 to kind of go and execute on it. So your design needs to be more detailed. It needs to be more clear so that anybody can pick it up and execute it. All right. And so these user journeys are very important. That how does, so in this case, let's say, for example, you would go and say, okay, step 1, let me think about and put yourself in the user's shoe. Okay, so think about yourself. What are you going to do if you want to create a tiny URL, right? First thing, you're going to log into a system, right? That's step 1. Then the second step is, okay, you're going to take that cut paste that long URL, right? And then paste it in and then click a button, right? And you click a submit button that will then return a short URL, right? So see how slowly I'm thinking about what I am doing and how I'm going to be, correct? So you will get a short URL, and then what are you going to do after that? You're going to take that short URL and then you are going to send it to your friend who on Facebook or WhatsApp or whatever, correct? So this is your user journey, correct? Now let's take an example. Maybe this time, Raquel, you can help us. What do you think is the user journey for a marketer?
To record where the actual transaction occurred.
Exactly. So the first 4 steps are going to be the same, right? But what marketer is going to be interested in step 5, where he wants to now see how many people clicked the URL, correct? And then maybe he wants to also know, like, from where they are coming, like are they coming from Facebook or they're coming from WhatsApp, right? So he wants to know all of that information about the so as a general user, you don't worry about analytics, but marketer is worried about analytics, right? So this is his user journey, correct? So one of the things that differentiates between a good engineer and a okay engineer is that a good engineer does not just care about the happy case. Okay, he is also very responsible for thinking about the negative cases and the auxiliary cases that can be associated with this journey. right? So what are negative cases? Negative cases are cases which can lead to a bad experience. So can you identify what negative use cases can you think about in this, in the primary journey? Raquel, what do you think? What would you think is the
A long lag time.
yeah, long lag time is a good one. Yeah. So when a short URL, but that is not associated with this user journey. I think it's mostly associated with the user journey where you click on the short URL and it takes a long time for it to redirect, right?
Yes.
For this, it will be like if a bad URL is being entered by the creator, right? So
Mm-hmm.
URL is being entered, then he doesn't know whether it's a bad or good URL, and he's going to just go and do all the thing, and later on he's going to get frustrated, right? So bad URL, we need to figure out a way to kind of stop bad URLs to be right. Also,
Yes.
it could be possible that he creates a URL which is not a bad URL, it's a good URL now, but tomorrow after 5 days that your site is no longer there. Then it becomes a bad URL. Then again, it's a bad experience for this guy. Correct? So these
Yes.
are some negative cases, right? I think I would say that 70th percent, like I think this is what differentiates between a FANG engineer and a non-FANG engineer. Right? They are thinking about negative cases and auxiliary cases. Auxiliary cases are other cases which are important but not that critical as the main journey. Okay, so these are like, okay, maybe this guy wants a timeout on the URL, right? He wants it to be not 90% of the 80% of the people are not going to think about this, but there might be 20% of the people who might be. Okay. And you don't, in the interview, you don't have to focus on this as much. You need to focus on the main journey and the negative journeys to make sure that your interview is. So you need to solve for these problems essentially. Okay. So the next third point is, okay, let's take this third step. Okay. Now that you have got the functional requirements correct, now this third step is non-functional requirements. Okay. Now here, what generally people end up doing is they start to kind of because this is what they've learned from the internet, right? What they learned is okay, sit down and do all the million calculations and bore the interviewer, right? By the time the interviewer he understands, oh yes, he's gone through this book from what's that one? System design. There's a common one, right? Grokking the system design. He just read that in common. Okay, so non-functional requirements only focus on three things because what you really want to do is get an idea. See, anytime you are trying to do system design of a complex system, right? It is all about getting an idea and then breaking it into smaller components, getting an idea and breaking it into smaller components. Yeah? You can't really think about everything at the very first go and say, okay, now I'm going to design. Right? So the thing that I tell people is just focus on scale. Okay. Focus on what I call as business latency. This is a new term. I don't think anybody must have heard about it, but I'll explain that. And the third thing that you need to focus on is essentially availability. Okay. Availability is more like to kind of get an idea as to, okay, am I trying to do a 99.9 percentile system or am I doing 99.99 available system, right? What is my budget essentially for this? Like for life critical things, you want to have at least 6 nines. Like if you are trying to do, these are some industry things that you learn with experience, right? That people tend to see, okay, 6 nines is what we want to spend on something like a 911 system versus 5 nines for, at the end of the day, what it is basically, if you look at the meta of it, right? Like how do you make this decision is what is the cost of the system going down versus keeping it up? Because it's both are costs. One, you have to pay in dollars if you want redundancy across multiple systems. And the other thing that you is to think about is what is the value loss. Let's say, for example, Amazon goes down for 1 hour. If the value of that downtime is $1 million loss in business, then it makes sense to spend $10,000 to $100,000 to keep the systems up and running. Right? In some cases, those losses are not quantifiable, like your loss of life, right? Or your loss in terms of face value or your reputation, right? So those are some things that are non-quantifiable, and so you need to spend money to keep those. So this is basically, that's the only, and what I think a lot of people that I meet, they don't understand this concept of why they should create, and then they come, okay, let me keep it as 99.995 why 5 nines, why not 6 nines? You know, so that's the question that people will ask you in your interviews, that hey, there's that cross questioning that you were talking about, Jay, right? Hey, why this versus, you know? Then the business latency is latency which impacts business. So it's not your API latency. Hey, I'll tell you what it is not. It's not your API latency. It is the latency that can impact the customer, like this fact that long lag thing that Raquel mentioned, right? That's what it is. How much lag should be there? And that it has to be a defined quantity. It has to be a defined value. Like 3 milliseconds, 5 milliseconds. I'm okay with a 2 millisecond lag, right? Then based on those business, and there is a business value to it. It's not like it's somebody's making could be possible that if it is at 100 millisecond lag, then the person is not going to use it. Your competitor has maybe 5 millisecond or 10 millisecond lag, right? So why would somebody come to your system? And so there is a business value to that. Scale in general is like how many people are using your system, right? How many people are using your system, and more importantly, how many people are using your system concurrently at peak. There are two terms here: concurrently and peak. Okay, so and that is what you want to design your system for, right? Because what I've seen people do is they'll design their system based on averages. Okay, so for example, let's say if you are Amazon, how many people are coming and shopping on Amazon on a daily basis, right? So they'll say, okay, well, the US population is around 330 million people, right? So let's say that 80% of the people, 20% of people come every day to Amazon to shop, right? So 300 million means 60 million people are coming to shop, right? So on average, on a daily basis, I'm going to see 60 million people. I'm going to divide that with the number of seconds in a day. So I think on a concurrently active people is going to be around, so what is 60 million, around 600 people per second, right? Right. And then, but that is not actually true, right? Because that's the average. Peak is going to be somewhere when everybody is either going to be off from work and they're home, they're doing some shopping, or early morning or afternoon, and they're having lunch sometime. So what should that number be? So what I typically say, hey, from anything that I've seen in my lifetime is basically, I haven't seen more than 10 times traffic go above the average. So let's design for 10 times the average, right? And of course, you need to be a little bit more mindful, right? Because every day, every minute, every second, 600 people are coming in. How long do they stay on the site? How long do they go and browse the product, right? All of these things have to be kind of figured out in your scale calculation. So this is just to give you, and you don't have to be really very, you have to be reasonably smart about it, in the sense that it shouldn't be off by a factor of 10 from what reality is, right? So there is some understanding of the world that you need to develop in order to come up with accurate numbers that reflect the reality. And you can do that. You can, this method that I use is called Fermi's method of estimation. And once you practice it, it becomes a lot of fun. Okay, you can start using it on your day-to-day basis as well. And you will see that the more you use it, the more accurate you will get. and the way you will start building intuition about the world around you, right? And start using it. So that's what scale is. So these are the three things that you should focus on when you are, because beyond this, if you start doing anything, it becomes boring for the interviewer. He knows that you have taken a template somewhere and they are just applying it. It doesn't really make sense, right? So that is this. Then the next thing is what I call as high level design. I think this is the most difficult part of the interview. Okay. And people think this probably is the easiest, but this is the place where you are going to create boxes. And the boxes it is very interesting that you need to create boxes and when you're creating boxes, what you're actually doing is you're creating abstractions. Right? You're breaking your problem into smaller components, right? And these components are then going to interact with each other. And that I think is the most difficult part. Of the rest of the stuff is just mathematics and easy. This is a little bit of art and experience that is required. So what I do is typically you will have a, take your user journey from the previous, have this user journey in front of you when you're because this is exactly what you want to go and depict it. So you have your user journey, and you have these boxes which are your services, which contain business logic and so forth, right? And so in this case, you have the login service, right? Because the very first thing that you mentioned here is that you're going to log in, right? So you have a login service, and then these arrows, these are your channels of communication. Okay, so you have to choose between different channels of communication, what is the best channel, right? And if you look at the channels of communication, you have API as one of your channels of communication, right? You have queues. Queues are basically asynchronous method of communication. Then you have files. You can use files to communicate data, right? Transfer data. You have WebSockets, right? You have polling, long polling, right? Any other you can think of, right? So these are different channels of communication. You have to put one of the channels across it. So the rule of thumb is that if you're looking for something which is less than maybe 200 milliseconds of latency, right? Then API is a good channel. If you don't care about latency as much, then queue is a good channel. Okay. If your file size or data transfer size is huge, then files are a good channel, right? If you are looking for less than 10 milliseconds of latency, then your WebSockets and your long polling are good channel. There's another one called server-side events. And if you're okay with some latency, right, between 10 to 100, 200 milliseconds, then polling is okay. So your login call, what channel do you think should this be? Right, it should be API, because you log in, you're okay with 200 milliseconds of latency, correct? And then you get a response back. So you're going to pass your username and password, and then you're going to get a token back, and that is your login authentication service. This service is going to have a database or a data source store behind it, right? Then go back to your next. What is the next thing you're going to do? You're going to put a short URL, a long URL, and you're going to get a short URL. Then you need a URL shortener service, correct? And this is again, you're going to pass in a long URL, and then you're going to get a short URL, correct? Again, you are going to use your API as your channel, right? And then once your URL shortener, then the next thing is, what is the next thing? Then the system it's outside the system. You are going and distributing this in some other places, right? And then somebody going to click that URL. I didn't do the user journey. Yeah, Jay, question?
Yeah, I have a question. So what service this URL will be, what service will be using to have this URL? Is it database or?
Service there. Can you repeat?
If you're hosting it on the cloud, maybe so Like what Azure service, let's say, we'll be using in this
Don't worry
situation?
about this, okay? Don't worry about right now.
Oh,
We're not even close to that. And this is
oh, okay, I see.
one big thing that people do. Okay, they start talking about technologies. High-level design is not about technology. It's just about how to break your system into components, and
Mm-hmm.
creating the right layer of abstractions.
I see. Okay.
Right? If you start talking about, hey, I'm going to use AWS service, this service, that service at this time, then they are going to direct points. They're going to say, hey, this guy he doesn't really know how to kind of, take a large complex system and because
Okay.
what happens is in large complex systems, you can't really get into this level of so early. You're
Right.
still
Okay.
figure out what is the nature of the services, what should we do,
Sure.
trade-offs do we need to kind of create.
Sure.
So,
Thank you.
right now, think about this. Don't even think when you're doing high-level design, don't even think about scale.
Hmm.
To think about scale, all you should focus on is, are your channels correct and are your abstractions correct? Okay. And this what I'm teaching you right now is a very simple way of doing it. Okay. It is I would say 98% accurate. If you follow this strategy, your abstractions are going to be accurate. But there is some chance where you still might there are some nuances behind it which I can't explain in this session. Okay. Any other question?
No, thank you, Rahul.
All right. So the next thing is, so now the next service that we're going to create is the redirect service, because I didn't go through that user journey, but there's another actor who's going to click on that and he's going to come here, right? So that actor is going to be redirected. So he's going to be putting a short URL and he's going to be redirected to a long URL, to the long URL, and then the browser automatically takes him to the site. Right? So this is the redirector. So now at this point, you can see that most of your functionality in this scenario is done, right? Now you need to think about maybe if you want to cover this guy, this is the marketer. So the marketer needs to have some sort of an analytics service, right? Some sort of an analytics service which takes data from this service about who is clicking, essentially, and storing it in the data store, right? So this is your analytics service. What is this channel? What channel would you use here? Raquel, what do you think?
Some type of location service.
No. So these are the channels, right? API, are you going to use a queue? Are you going to use a file system? Are you going to use?
Oh, I would say API.
Yeah,
I'll
so
go.
your API, so this is the thing, right? Does this guy really care about latency?
No.
No. So here the APIs are only used when you want to be less than between 200 milliseconds to hundreds of milliseconds of latency is what you're expecting. Here you don't really care about it, right? So here the right channel would be a queue, because the queue is an asynchronous channel where you just keep on pushing the data and this guy doesn't really care about it. This guy takes his own sweet time to, right? And the analytics guy, he's sitting here, he can wait for tens of seconds in terms of, right? If his data is, of course, if his requirement, the business latency is that he wants to know every 100 milliseconds, then also queue can be okay, because it's still reasonable, because this guy really doesn't care about it, he cares about it. This guy cares about it. But if it is tens of seconds, then definitely a queue, not an API.
Okay.
Right. So that's the channels, and so now we have a good ecosystem. We have a good way to go about doing this as well as this, correct? And now comes the detailed design. Okay, so detailed design, and this is where your question, Jay, is essentially when you started this thing, we were talking about how we are going to how are we going to make these trade-off decisions, right? in system design, there are 5 parameters that you make decisions on. Okay, there is latency, there is read load, there is write load, there is consistency versus availability, the cap, and there is storage. Okay, and so you have to basically figure out this matrix, right? So if you take this service, this API, this has to be done at an API level. Okay, so for every API, you have to kind of come up with, hey, what can the latency be? Okay, so if you look at the distance from the world, right, in the world, like from East Coast to West Coast, right, you can see that this is a latency of 100 milliseconds or so, right? So if your user is sitting in East Coast and your service is in West Coast, you're automatically adding 100 milliseconds here. The latency within the service network is going to be very small, which will be like if you're accessing a database, it's going to be 10 milliseconds. So these are some numbers that you can find on the internet. There's a good article there which says about, hey, what are the various latencies across across different layers and different, like if it's in RAM, what is the latency? If it is in memory, what is the latency? If it is in disk, what is latency? You know, all of that stuff is very much documented. So you can get an idea of what that latency, and now you need to make sure that this latency number that you came up with, is it acceptable for the user, right? Similarly, your read load, what is the read load and what is the write load? And then can your ecosystem handle that read load versus write load? Right. And then finally, consistency, right? What is the consistency that you are going to be expecting? Correct. And then storage. You need to now here, this is the place where you need to do those calculations that grokking the system design talks about. You can't do these calculations up ahead because you don't know what your system is. So how are you going to even do those calculations, right? So now you come up with these calculations and then you see, okay, whether your system that you designed, does it match? Or, you know, and the objective is to create the cheapest system and the simplest system that matches the parameters that you're looking for. Okay. So I think for today we'll stop here.